Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter moving charges and magnetism. Okay, so let's go through the question. The question is, a wire carrying a current I along the positive x-axis has length L. It is kept in a magnetic field. This magnetic field is given in Tesla, that is the SI unit. The magnitude of the magnetic force acting on the wire is how much? Okay, question came in NEET 2023, very basic question. Okay, so here we have to calculate the magnetic force, and what is the magnetic force formula acting on the current carrying conductor? It is given by I L cross B. What is the formula here? See, this is the formula I L cross B. Okay, this formula have to remember that here. This is the basic formula. Is it? Basic formula. Now after that here we will note down here the given data. Okay. So first remember that here as this L is the water, this L is the, this I into L, that is called the current element. Is it? I into L is called water current element, because you know very well current is a scalar quantity, but when you will take I into L it becomes vector quantity, and that is the current element. Okay. So here this length, length in which direction? The wire is having length L. Along which axis? X-axis. Okay, so see here please. Here I will write here this vector L, it is given here L into I cap, because in which direction? Positive x-axis. If in case they told negative x-axis, you have to write L into minus I cap. Okay. After that, next thing, if we talk about here the magnetic field, it is given here, you can see here 2I cap plus 3J cap minus 4K cap. Is it? Now after that here we will use this formula. Okay, so from here if I calculate here the magnetic force, the value current is I, current I is given here, this I is there. After that we'll put here the value. What is the length? Length is given here Li cap. Okay, right here please, Li cap cross, very basic we are doing. Magnetic field it is given here, see, 2I cap plus 3J cap minus 4K cap. Here we have to take the cross product. Cross product can be done by normal method also and determinant method also. But here determinant method, no need, because very simple is there. So see here, this is I, and here just multiply L into 2, it will become here 2L, and it will become here C I cap cross I cap. Okay, plus L into 3, that means 3L, and it will become here C, same order, I cap cross J cap. First I cap, then J cap. So we have to write I cap cross J cap. Don't write J cap cross I cap. Okay. After that, see, minus, this is L, this is 4. So we can write here 4L, and first I cap and then K cap. So we'll write here the I cap cross K cap. Why we are doing like this? Because cross product of the vector is not a commutative. That means I cap cross J cap and J cap cross I cap, they are not same. Okay. Now after that here, see, this will become here I, and here 2L I cap cross I cap, it will be unit vector. Unit vector or null vector? Null vector, because I cap cross I cap used to be the 0. Okay, null vector. Plus 3L I cap cross J cap, it will be K cap. Okay, K cap minus 4L, and I cap cross K cap, it will be minus J cap. Is it? Like this. And why I am using this basic? Please remember that here, if in case there is the one circle, and if in case we are moving in an anti-clockwise direction like this here, like this, no? So in this situation, all will be positive. I cap cross J cap, K cap, J cap cross K cap, I cap, K cap cross I cap, J cap. Is it? So this is the positive. But if in case we are going in a reverse direction, try to understand please here, no? If in case the arrows are reverse, no? Basic I am telling you. Here we are writing here I cap, then I am writing here K cap, and I am writing here J cap. Then we have to take here minus sign. That means when we are writing J cap cross I cap minus K cap, I cap cross K cap minus J cap, K cap cross J cap minus I cap. Okay. So remember that here, anti-clockwise positive, clockwise negative. Is it? From there only I have written. So now what this will become here, see, this is I, and this is anyhow 0 only. No? This is 0 only, so it will become here 3L K cap minus minus plus 4L J cap. Is it? What are the things are common? That will come outside, so we can take here L into I, and what will come here? See here 3I cap plus it will become here 4j cap. Now this is a vector form. This is which form here? Students say this is a vector form. But what they are asking here the magnitude. Okay. So if I want to calculate here the magnitude, see I am writing here the magnitude. So this magnitude of the force L into I as it is square root of 3k cap plus 4j cap means coefficient of k cap square plus coefficient of j cap square. So what we can write here? 3 square plus 4 square. The basic formula is that square root of coefficient of I cap square plus coefficient of j cap square plus coefficient of k cap square. Okay, but here I cap is not missing, so we are just writing coefficient of k cap square and coefficient of j cap square with square root sign. Then what this will become here? See, L into I, 3 square plus 4 square, 9 plus 16, 15 square root of 25, 5. Is it? So it is coming Li into 5. Where is Li into 5? You can see very well. See here, 5I. Can you see very well? Is it? So students, I hope so. This mathematical calculation and very basic question of magnetic force is very clear to you. Keep studying, keep growing.